Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. So thank you very much, students, for your time you give to see this recording of the materials. So right now we are going to learn about the fifth material, I think, because actually it is fourth material, right? But in the fourth week, we gonna have the first quiz. Yeah, so this is actually fourth material, but it is delivered on the fifth week. Yeah, so our topic today is about the index and query optimizations. Yeah. So here is our agenda today. We have six actually. The four of the agendas are gonna explained by me in this theoretical explanation, yeah, in this PowerPoint. And the the other tools will be discussed in the lab guide. Yeah. So the topics are the first is basic concept of index, and then followed by query performance analysis, and also creating and managing indexes. After that, we learn also about the query optimization with index. Yeah. And other than that, we have two exercises. Yeah. So the first one, it is how for us to create or managing index, basic index, right? And then also we have one more exercise about the query optimization and also trade-off whenever we are using index. Okay, so let's discuss about the first topic. It is about the basic concept of the index. So what is index? Yeah, so index is actually some kinds of additional data structures that is created on top of a table to speed up the query process. Yeah, so if you imagine a book, yeah, if you have a book, for example, like 100 pages, and then you want to find some page, yeah, some page about some topic, maybe the book title is about database, advanced database, and then you want to find a topic named, for example, like join. Yeah. So how can you find a page that containing the join topics? Of course, usually if you buy a normal book, you will see in the index, yeah, or in the table of contents, right? And then you can easily find, you can search there the A, B, C, D, and you find topics about join, and it will be given the corresponding page, and you open the page. For example, if the page is 156, then you can easily find that the page containing the join topic is in that particular numbers. Yeah. So you can be easier in finding those pages because of course you are provided with the table of contents. Yeah. So the same thing, the similar thing, yeah, it is is there in the DBMS, especially in this PostgreSQL. So in order to find the data, usually if you are using the select statement, select blah 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 from table blah 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 where blah blah blah. So in the where statement, it is contain the condition for the particular data that you want to find. So what will the database do? The database will search one by one, record by record, one row by row, one by one. Yeah. So it will take several amount of time until it finds the data that you look for, that you're looking for. Yeah. So in order for the DBMS to be easier in finding the data that you are looking for, it needs something like the table of contents. The same goes like you have a previous book that I already told you. Yeah. So without that table of contents, the database will struggle in finding those data because if the data, especially having more than maybe 1,000 or maybe 1 million rows, yeah, the database will go through those rows one by one until it finds the data that we are looking for. Yeah, so it will take a lot amount of time. Yeah, so in order to the database to be easier in finding those data, we need to provide the database itself, the database engine, the PostgreSQL, the index. Yeah. So index is something that helps the DBMS to find the data that we are looking for. Yeah. So without an index, PostgreSQL must read the entire row. Yeah. So this is called by sequential scan. So it will scan one by one until it find the data. So with uh, but, but without an index, the PostgreSQL will find the data that we are looking for one by one. But with the index, I'm sorry, this is I think this is a typo. Yeah, so actually this is with index. Yeah, so with index, PostgreSQL will simply search the index structure and then go directly to the relevant row. Yeah, so this is called by index scan. So this is index in a nutshell. Yeah, so about how we create something that makes the work of DBMS engine become a lot of easier when they are looking data, certain data. So why is it important? Of course, first one is about the speed. So in the modern applications, speed is one of the most important factors that defining the success story of an application. So if you have application and then your users feels that your application is so slow, of course they will leave your application and they will choose maybe another applications. Yeah. So speed is important. By using index, the database will be very much easier in finding the data that users look. Yeah. Of course, and then of course the second is about the resource efficiency. So sequential search or searching one by one, row by row, it will take a lot of amount of resources. Yeah, so compared to the index, yeah, just like when we are looking at a table of contents in our book, yeah, so it is easier for us. So it is less tiring for us if we have table of content. So we just need to take a look some of the characters of some of lines of sentence, yeah, maybe the topic's title, and then we can easily find the page that we are looking for. And then after that, we just flip the books and go to the number of the page, for example, like 156, yeah, like before. But if we don't have like the table of contents, we have to waste our energy to open one by one. Yeah. So looking through all of the page, yeah, finding where is the join. Yeah. So first page, this is not join. Second page, this is not join. Third page, this is not join, and so on until we find the page about join. Yeah. So this is of course about the resource efficiency. By implementing an index, we can make sure that the resource of our computer or our server is utilized efficiently, more efficiently. Yeah, and then the second one is also this index is supporting is created to support complex operations. For example, if we are using, for example, sorting, yeah, so we need to sort the data. Usually in applications like Instagram, yeah, there are uh some some order for the post. Yeah. It is common, yeah, when we are using Instagram. So we will get the contents that is, for example, most popular first or the newest one first. Yeah. So there are certain index in the data. Whenever we want to sort the data, so we will need these indexes. Yeah. And then other operations may be about the full text search. Maybe this one is topic. This is a topic that you haven't learned whenever you learn the basic database course. Yeah, about the full text search. What is full text search? Full text search is when you want to find a string that is not really the same. Yeah. For example, in English language, usually if you want to find a word about it, yeah, compared to eating, it is different. Yeah. If you are not using a full text search, whenever you search word eat, yeah, so eating will not be included. But if you use the full text search, it is a special features of PostgreSQL. So it will needs index also in order to fasten your search. Yeah. Okay, and also special queries. For example, if you build geographical information systems applications, yeah, of course you will need this index to fasten your process of searching. And then also if you often try to join more than one tables, but each of those tables having lots of records, then of course you will also need index. So this is why index index is important. Index concept is important. Yeah. Okay. So how it works? Yeah. For example, we have this simple query, right? Like this one. Select all, yeah, from the pelanggan tables where email equals to pelanggan12345 at mail.com. Yeah, so without index, the PostgreSQL will do the sequential scan. It will check row 1, row 2, row 3, row 4 until those data is found. Yeah. For large amount of data, for example, like 50,000 lines, the worst case is that the PostgreSQL will look through all of the data, 50,000 lines, and it will cause your applications to become slower. Yeah. And what if the PostgreSQL work with index? So what happens when we provide the index for those tables? So for example, if we create an index in the those pelanggan means customer, right? So in the customer tables, we create an index on email column. So we can put index in a table in a certain column. Yeah, for example, in this case, we put the index in the email column. Yeah, so what happened? So PostgreSQL will store the B3 data structure behind the scenes. Yeah, so B3 is balance tree. Yeah, this is the data structures like tree. So it has branch, yeah, and it has node, yeah, something like that. And then the customer emails will be stored, yeah, will be stored in those tree. Yeah. So the PostgreSQL will just go through the tree for log to and steps. Yeah. So this is much faster. Yeah. It is much faster compared to the sequential scan. So but what is the log n? Yeah, I will explain. I will explain later. Yeah. So for 50,000 rows, it only takes for plus minus 16 steps. Yeah. So it is a lot of faster compared to the sequential scan. Yeah. So please take a look here. Yeah. So 50 for sequential scan, we will have 50,000, yeah, at most. Yeah, in the worst case scenario, it will look for the step needed to find the data is plus minus 50,000 times. Yeah. But if we are using index, it will take only 16 steps. Yeah. So can you imagine that? Yeah. So 50,000 versus 16. This is, of course, yeah, so much faster when we are using index. So we have about simple analogy here. So without an index, it is like searching for the word indexing, for example, yeah, in the 10, in a 1,000 page book by reading page 1 until page 1,000. Yeah. For example, if we have topic indexing in a database book, but this topic is positioned in the last page of the book, yeah, in the book, in the page 1,000. So whenever we are looking this topic without any table of contents, so it is like of course we will find one by one, yeah, from page 1 until page 1,000. However, when we have index, so we just need to open the table of contents and then go directly to certain page that contains the topic that we are looking for. Yeah, so this is in general how the indexes work. Then this is about the complexity of the operations of the algorithm in computer science. Yeah. So I'm sorry, I forgot to translate this one. Yeah, so this is meaning that what does it mean by log to n? Yeah, so if we're creating an algorithm, so the algorithm will have cost. For example, the time. The cost will be based on the input of this algorithm. For example, if we have one input, yeah, and then our algorithm will take 1 second, and when we have 10 input, and our algorithm will take 10 seconds to process, and when we have 1,000 input, our algorithm will take 1000 seconds to process, so it will be called uh, big ON, yeah, big ON notation. So the line is here. Yeah, so this is the comparison between the performance of big O notations. Yeah. So the faster one, the fastest one is the green one, is the green ones, and um, the the bad one is they are in the red there, red side here. Yeah. So for example, whenever we have one input and then it takes 1 second, two input, 2 second, three input, 3 seconds. So the number of input is linearly increasing. Yeah. It will be called by big ON notation. This one, yeah, in the yellow. Yeah. So take a note here that ON, big ON notation is on the is considered as fair, yeah, fair, not good enough, yeah, and of course not excellent. And the best one is of course big O1. Yeah. So uh, whatever the data, whatever the inputs is, yeah, the time it takes is only 1 second. Yeah. For example, if we have one input, then it will take 1 second. 10 input, it also still 1 second. 1 million input, it is still 1 second. So this is the perfect, yeah, the perfect performance of algorithm. So if we can create an algorithm that with that has complexity of O1, it is considered as excellent, yeah, excellent performance. And you can take a look here in log2n, yeah, log2n. So log2n is in, I think it is in here, yeah, log n here. This is actually considered also as good, yeah, as good, yeah. This is good performance. So what is log2n? It means that whenever the input uh, in double, yeah, increasing in double, yeah. So the times it takes will increase by 1. Yeah. For example, if we have 0 input, it will take maybe 1 second, yeah. And then if we have 2 input, yeah, it will become 1 second. If we have 4 inputs, it will become 2 seconds. So each time the input gets doubled, yeah, the time will increase by just 1. Yeah. So this is what we mean by the log2n, yeah, notation. Okay, so the meaning is that every time the n increase in double, yeah, so multiplied by 2, every time the n is multiplied by 2, the value of log2n only increase by 1. Yeah, so this is considered as good, yeah, good performance algorithm. So the difference is so much, yeah, compared to the ON, yeah, ON notation. Okay, next. So now we are going to discuss about the types of index. In the PostgreSQL, there are 5 types of index. It is B-tree, spatial, yeah, or hash, and then gin, and also gist, yeah, and also print. Yeah. So now we will discuss it one by one. If actually this is not needed for us when we just learning about how to use PostgreSQL. Actually, it's more like the concept. So if you confused about this one, you don't worry about that. It is just information for you. So we are not going to modify the tree or something like that. Yeah, it is actually not the realm of our uh, software engineering, yeah, topics. If you want to go through the detail of the algorithm, you can maybe take a course on the computer science, yeah, for master degree. Yeah. Okay, so let's just review. Let's just get to know about what is B-tree, spatial, gene, and gist, print, yeah, index. Yeah. This is just for our informations. I will not tell in detail. I will only tell when this is good for use, and or when is always, or when is the index is not good to use. Okay. So the first one is the B-tree index. So B-tree is the default index of PostgreSQL. So whenever we create index without specifying the types of the index itself, the PostgreSQL will create the B-tree, yeah, B-tree structure for the index. B-tree stands for balanced data tree. and it is stored in an orderly order so that the search can be done quickly with logarithmic or log n. Okay, this B-tree is the usage of this type of index usually is suitable for the equality search. For example, if we have where statement with equals or not equals, yeah, and also range, for example, like less than, more than, or between searches, and it can speed up also the order by and distinct, yeah, distinct statements. So this is the example. So for example, this is we want to create an index on pelanggan tables in the email column. Yeah. So the syntax is like this: create index. This is the name of the index. IDX means index. Yeah. So IDX underscores pelanggan underscores email. This means that the index will be created on a pelanggan table in the email column. Yeah. Okay, then whenever we are using this query, this index will be utilized. Yeah, for example, select all from pelanggan where email equals to the value of the emails that we are going to search. Yeah, so whenever we run these queries, this index that we have created before will be utilized by the PostgreSQL. Yeah. All right. Yeah. All right, so this is also, yeah, for the second query, select all from transaksi. Transaksi means transactions, where tanggal transaksi between this one. So whenever we are running query select like this, yeah, select query like this. So the index that we have created before will also be utilized. Yeah. So the index will be utilized by the DBMS whenever we run a query that is related to certain columns that we put the index before. Yeah. So for example, here we are um, we are putting the index on the pelanggan, and also actually we create also index in the tanggal transaksi column or transaction state. Yeah. So I forgot to put the second index statement, create statement. Yeah. So actually we create one index on pelanggan table and also one index on the transaction table. Yeah. So but I forgot to put the second query of index creation. Yeah. I only put the SQL syntax for index in the pelanggan table, but I forgot to add also the query that is created in the transaction table. Yeah. Okay, so this is the example of the B-tree index. So B-tree index is the default index whenever we are not specifying any types of the index. So the PostgreSQL will create the B-tree index for us by default. Yeah. Okay, then the second type is the hash index. Yeah. So what is hash? Yeah, hash actually is kind of function to encrypt a data. Yeah. So this hash index is using the hashing function to create a hash value of a column. If the search will be quick, but it can only be good for the equality check. Yeah. So this hash, the hash type index is good, yeah, whenever we are running select query that is kind of the equality check for or when we are using the equals, yeah, equals operator. Okay, yeah, sorry. So the usage is good for whenever we are using equality check or columns equals values. And it will be not very good when we are using for range query, for example, like less than, more than, or between. Yeah. And this is the example of the usage. For example, please pay attention on the difference of the syntax versus the previous one. So if the previous one we are creating index without specifying the index type, just creating the index done, yeah. So we will be given the B tree index or balanced data tree. But we can also specify the index type. For example, like here, when we want to create an index that has the type of a hash. Yeah. So create index, the syntax is the same. Create index, the name of the index, and then on the table name, and then using meaning that we want to create index with certain types. Yeah. So in here, in this case, we are using the hash type. Yeah. So using hash, and then this is the email column. So this index will be utilized by the PostgreSQL whenever we are running the SQL something like this. Ya. Select all, for example, select all from pelanggan where email equals ya, pelanggan 123 pelanggan 12345 @mail.com. So it will be very useful. It will be very quick whenever we have some query something like this. Yeah. Okay. Okay, yeah. So this is the for actually in the older version of the PostgreSQL, the hash index was not WHL locked. Yeah. WHL log is a special term for write ahead logging. Yeah, this is actually special features of the PostgreSQL. So in the previous version of PostgreSQL, it is not crash shift. Yeah, it can crash, yeah, sometimes, but since the new PostgreSQL version, it is now easier to use, yeah. But still, yeah, when we are not having certain specific, yeah, specific specific things to consider, so we are free to use the B3, yeah, because B3 itself is the default one, and it is um, uh, fast, yeah, fast and flexible enough when we are wanting to use the select the SQL select. Yeah. So compared to the hashing, the B3 is also suitable for the range query. Yeah. But when it is coming to the hash type of the index, it is only suitable for the equality check, yeah, something like this one. Okay. Then come the next type of the index. It is GIN, yeah, or generalized inverted index. It is index that is useful whenever we want to perform full text search. For example, when we are using the function 2ts vector and also 2ts query. Yeah, so what is the full text search? I think I already mentioned before. Full text search is um, whenever we want to search whenever we want to search string based on similarity, not based on the exact, yeah, exact value. Yeah, for example, when we want to find a word study, yeah, but in the table there are only the word studied, for example, yeah, studied or studying. Yeah. Whenever we are using just simple string comparison, the word of studying or studied uh, will not shown to us in such case. Yeah. But when we are using the full text search, the string that is similar to the key that we are searching is also will be shown to us. Yeah. So this is the full text search. If you have column, yeah, if you have column that is usually will be queried by using the full text search scenario, then it is the best for you to apply this GIN index. Yeah. So it will make your process will make your full text query much faster compared to when you are using the B3 index. Yeah. Okay, so this is example of the use of the GIN index. Yeah. So for example, we create index IDX product description GIN on product using GIN to TS vector English description. Yeah. So this means that we are create an index. The name of the index is this one, IDX product description. This means that we create an index with in the product table in the column description with the type of kin. Yeah. On product using kin to TS vector English, and this is the description column. So this means that we want to we want to perform, yeah, we want to perform the full text search on the description column using this one 2ts vector. Then when we create this query by using select all from product where 2ts vector English description add ya, 2ts query laptop and gaming. So it will provide us ya any description that contains laptop or gaming or both of them or any other string that is similar to the laptop and gaming, yeah, and gaming words. So this is how the other usage example, but this time on array data type. So this one is create index IDX tag skin on article using kin, using kin text. So this means that we are creating a kin index, uh, in tags, in tags column, in tags column, on article, yeah. So we are creating an index on an article table. Yeah, I'm sorry because the naming is not similar with before. Yeah, so create index. This is the name of the index. Actually, we can put any name on our index. Yeah. So whenever I write here like idx underscore tax underscore, this is actually I want to show you how to follow the conventions. But I myself yeah forgot to follow the rules in this index. Yeah. So create index idx tax kin on article using kin text. Yeah. It means that I am creating an index on the article table using kin, yeah, in the column text. And then whenever we are searching the text, the data in this column, in the text column, like this one, select all from article, well, where text is in this one in the form of array, so this index will be utilized. Yeah. So important things to note here that is that whenever we are creating index, it is not necessarily will always be used by the database. Well, will always be used by the PostgreSQL. So PostgreSQL will only use our created index by whenever it is needed. Yeah, for example, when a select query that is related to the column that has the particular index is run, yeah, is executed. Okay, so this is the gain index is good, yeah, for you if you have column, yeah, and then you want to perform the full text search or array search on that column. Yeah. Okay, the fourth type is the generalized search tree, yeah, search tree index. Yeah. This is a flexible index framework. It can be used for many types of data, and it is also suitable for the data needs that is similarity sets or multi-dimensional range. Yeah, so it is good whenever we want to use it in a spatial or geometric data. Yeah, for example, like coordinates, maps, or keys, and it's also in the full text alternative. Yeah, for example, like trigram search and also similarity search. Yes, this is quite similar to the the previous index, the generalized inverted index. But if this one is specialized whenever we want to search like full text search and also array, and this generalized search tree, it is useful whenever we need to search similarity and also the geometric or spatial data. And this is often used with the PostGIS. So PostGIS is like add-ons or a plugin for the PostgreSQL, yeah, that is usually used by the developer of geographical information systems application. Yeah. Okay, it is more flexible than GIN, but sometimes but sometimes it is slower for the simple text sets. Yeah. Okay. So this is important thing to note. The generalized search tree can be very fast, yeah, faster than GIN and more flexible. But whenever our columns it just has a small text, yeah, it will become slower compared to the GIN index. So this is the two examples of using the usage of kin index whenever we are using in geometry and also trigram search. Yeah, this is the geometry, the example for the geometry. So create index. This is we are creating an index. This is the name of the index. And we are creating the index on the location table. Yeah, lokasi means location. Using gist, yeah, generalized search tree on the geom column. Yeah, this is a column named geom. And then whenever we perform a query like this, select all from lokasi where std within. This is the example of geographical function, special function in PostGIS. Yeah. Uh, and then we put here the geometry, the geom column, yeah, and then this is the point. Yeah, this is just example. Don't worry about this one. Yeah, don't get confused about this one. This is I just want to show you when will be the gist index is used by the PostgreSQL. Yeah. So this is because in this select statement we are using the geom column, and the geom column itself has the IDX lokasi gist index. So this index will be utilized, will be used by the PostgreSQL. And then the next example when we are using the query to perform the trigram search. Yeah. For example, like this one, select. So we are activating the extension first. This is usually only once. Yeah. Okay. And then whenever we after we create the extension, we can create the index. For example, like this, create index IDX product nama TRGM. This is the meaning of this is trigram. Yeah. On product using gist. Yeah. It means that we want to use the gist index in this product table. Yeah. Gist in this column. Nama produk ya gist TRGM ops ya operation. Ya. Then for example trigram search is whenever we whenever a user might be in our application, they want actually to search laptop, but the users accidentally types P two times. Yeah. So for example, here laptop with double P. Whenever we are performing the simple search, of course, this product will not be found. Yeah, will not be found because it is not exactly the same with laptop. Yeah. But if we are performing with the Telegram search, yeah, this data will be shown. Yeah, laptop will still be shown. Yeah, this is just like the Google. Whenever we are searching something with typos, usually Google will correct it for us. Yeah. So this is the example of the query. Whenever we have query something like this, yeah, so the index that we have created before will be utilized by the PostgreSQL. Yeah, so this is the fourth type of index, the generalized search tree. Yeah. And this is the fifth type of index. It is called BRIN or block range index. Yeah. So, how does it work? Yeah, so it doesn't store pointers to each row, but only stores a summary per block or min-max value range. It is very space saving. The index can be thousand of times smaller than the B3. Yeah. So, you need to understand that whenever we create an index, it will actually cost us some space in our hard disk. Yeah. So it is not necessarily when after you learn about index and then you create index for every tables and every columns that you have. No. Yeah. So you just want to create index that is in a column that is usually perform select query on it. Yeah. So we don't need to put index. We don't need to create index for every column in every table that we have. Yeah. Because the index itself will cost us some amount of storage. Yeah. Uh, and there are also particular types of index that is very space saving. Yeah, it is called print. Yeah, so print is working in such a way that it will only cost us small portions of the storage compared to the other of indexes that I have already explained before. Yeah, so it is good, but it is good in a certain case. Yeah, for example, like whenever the data itself is naturally sorted. Yeah. So for example, like dates or IDs or log data. Yeah, so if we have data, for example, like when we are creating application like Google Forms, when our user will be our users input will be recorded based on the date, based on the time when they fill the form. Yeah, so it is one example of the naturally sorted data. So the data itself will whenever the new data is added, of course the date will be later, right? So whenever a user input uh, writing their input into our form, yeah, right now, and then other user write again in the next few minutes, of course the data will be automatically sorted. Yeah, the order will be in the bottom. Yeah, so this is what I mean by the naturally sorted data. And whenever we have a data something like that, yeah, the print index will be good for us. And also it will be suitable for the append-only tables, for example, like sensor data, daily transaction, or server logs. Yeah. What is append-only tables? Append-only tables is a table that containing data. There is seldomly, this is seldomly updated. Yeah. So for example, like sensor data, whenever you create an application using IoT, for example, or certain types of sensors. Yeah, the sensor data will be appended, will be inserted, yeah, continuously to the table. This is what I mean by append-only table. The record data, the sensor data will not be updated usually. Yeah. So if you encounter some cases like this one, so Brin index is your choice. Yeah. So you can use this Brin index because it will it will save us, yeah, a large amount of storage compared to the other index for these specific cases. This is the example of the usage. So, for example, we want to create an index in a transaksi table, in a transaction tables, yeah, using print on the column tanggal transaksi, yeah, or transaction date. This is one example of the append only tables, yeah, and it is also naturally sorted. So we create index first, and then whenever we are performing some query like this one, ya, select all from transaksi where tanggal transaksi between something and something. So this index will be utilized by the PostgreSQL. Yeah. So the advantages of this index is it is very small and quick to make, and it is ideal for the tables of hundreds of millions and billions of rows. But don't forget this one. Yeah. So this is not large amount of data that having any characteristic, but this must be they must be having some this specific characteristic. So it is naturally sorted or it is append only. Yeah. And the disadvantages of this index is that it is less accurate than B3, and PostgreSQL is still possible to read irrelevant blocks. So this is the type of the indexes that we have learned today. Yeah. So this is the summary of the five types of the indexes. So we have B3, we have hash, we have gin, we have gist, we have and we have also print. Yeah. So B3 is suitable for equality and range. Its size here meaning the size of index. Yeah. So remember I said before that whenever we create an index, it will cost us some amount of storage. Yeah. So B3 here is considered as medium size, and it is the default index and most often used. Yeah. Okay, and then the next one is hash. This is suitable for equality only, and the size also medium, but it only used in equality. Yeah. So we can prefer, yeah, we can choose B3 actually over the hash index. Yeah. And kin is used for full text array and JSON. This is the size of kin index is large, and it is whenever we use any query that like the search engine. Yeah. Then we have GIST. It is special for The spatial suitable for spatial similarity or trigram sets, and the size is medium to large, and it is flexible, usually used in PostGIS. And we have also print, it is for big and sorted data, for example, like dates or sensor data, something like that. And it is also must be append only table, yeah. And the size is very small, and it is suitable for tables that have more than 1,100 million rows, yeah. Okay. All right. Uh, So now maybe you will have questions. Yeah. So, Pak, is this index concept also available in MySQL? Yeah, the answer is of course yes. Yeah. But still, yeah, because the class of the MySQL is different from the PostgreSQL. Remember, PostgreSQL is considered as enterprise database. Yeah. Of course, the quality of the index will be also different. Yeah. So in the PostgreSQL, this is the default index is the B3. It is fully supported by using the create index syntax, and then it's also suitable for the general operation like the equality, range, less than, more than, between, and order by. In the MySQL, we especially in the InnoDB engine, yeah, InnoDB engine. So for your information, MySQL actually have several types of different engine, and the most popular one is this one, InnoDB. Yeah. So B3 is also the default index type, but the implementation in MySQL is only for equality and range. Yeah. It is less flexible than the PostgreSQL. If the PostgreSQL's B3, it is also suitable for between and order by. Yeah. In MySQL, the B3 is only suitable for the equality and range. Yeah. But then InnoDB index also stores raw data in a clustered index, yeah, or primary key. So this is the comparison, yeah, between the PostgreSQL and MySQL. So for the B3 index type, it is fully supported in the PostgreSQL. In MySQL, this is also supported, but it is limited to the equality and range. For a hash index, it is natively supported since PostgreSQL version 10. It is not supported, but in MySQL, it is not supported in InnoDB, only in memory engine, but it is rarely used. And GIN index, it is in PostgreSQL, it is fully supported for full text sets, array, and JSONB. In MySQL, it is not supported. For GIST, it is for spatial, trigram, and similarity. It is fully supported in PostgreSQL. In MySQL, it is not supported. For BRIN, it is good for saving space for big and sorted data. In MySQL, it is no direct equivalent. And for full text sets, in PostgreSQL, we can utilize the GIN or GST index. But in MySQL, it is also natively supported in UDB since version 5.6 for text only. Yeah. So this is uh, all about the basic concept of the index. Yeah. So in general, PostgreSQL excels in variety of index type. It has GIN, GIS, print, JSONB array, and also advanced full text. In MySQL, the index capability is more limited. The majority is only B3 and full text and spatial, but with the access of only default clustered index in InnoDB. Yeah. If you want to focus on data analysis, full text or GIS or JSON PostgreSQL are richer. It can be your choice. But if you just creating a simple or standard OLTP applications, it is enough for you to use MySQL. So this the comparison with the MySQL. Okay, next is the second topic. We want to discuss about the query performance analysis. Okay, so query performance analysis is the process of evaluating how a database executes a query to find out whether the query is efficient or slow, why it is slow, and also how to fix it. Yeah. And in other words, this is how we pick into the PostgreSQL kitchen. Yeah, this is Indonesian idiom. So we pick into the PostgreSQL kitchen. We want to see the query execution plan and the cost of each step. So every query that we type and run in PostgreSQL will have cost. Yeah. So by doing this performance analysis, we can see the cost, we can see the plan. Yeah. So we can determine whether this query can be optimized or not. Yeah. This is the main goal of the query performance analysis. So why is important? Of course, because the large data sets is equals to the risk of slow query. So whenever your data is getting bigger, of course, the risk of your slower query will also increase. Yeah. Also about the resource optimization. Yeah. So we want to optimize the resource. We don't want to waste the resource because particularly when you are using cloud computing, whenever you use a large resource, it means that you will spend more money on it. Yeah. So we want to optimize our resource. And also the main goal is also to ensure whether we to ensuring that we already use proper index in the in any table or any columns that we query. We query often. We often queries. Yeah, and also it is useful when we want to detect the bottlenecks. Yeah. So sometimes some query can be faster and the other might be slower. Yeah, so we can also detect these types of bottleneck by using the query performance analysis, and we can do this one by using the third, sorry, not third but three, by using three features from the PostgreSQLs, which are explain. The first one is explain, the second one is explain analyze, and then the third one is PG statements. Yeah. So now we are going to discuss each of the syntax. Yeah. Okay. The first one is explain. So explain is a command in the PostgreSQL to view a query execution plan without actually running the query. Yeah. So for example, we have some query like this one, select all from pelanggan where email, blah blah blah. Yeah. So we want to analyze. Yeah. We want to analyze the cost. Yeah. The execution of this query using which kind of index. We can put explain in the front of the statement. For example, this is our statement, yeah, original statement. Select all from blah blah blah, and then put explain before the select statement. Whenever you execute this query, yeah, the PostgreSQL will check, yeah, will analyze, yeah, without running the actual query. Yeah, this query is not running actually. Yeah, just will be analyzed by PostgreSQL, and then it will show the result to us. Yeah. So for example, this one, yeah, whenever we put explain in this select statement, it will give result something like this. So blah 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 scan on the table names, yeah, for example here, yeah, and then the cost. Yeah, it will gives us two things actually: the types of the sets and also the cost. Yeah, the cost. Yeah. So this means that this sec scan, meaning that this PostgreSQL is using sequential scan, or in other words, there are no index in this column. In this email column, in this pelanggan table, there are no index. Yeah. So the result of explain will be like this: SEQ scan. This means sequential scans. Yeah. If you find like this, so it means you don't have index in this column. Yeah. So, but if you already have index in a column or a table in the email, for in this case is email column, the result will be something like this. So index scan instead of sequential scan, yeah, it will be index scan using in IDX pelanggan email on pelanggan. This means that we have already an index in pelanggan table in email column, and the name of the index is IDX pelanggan table. Yeah. So you can see here the cost is very different. Yeah. So this is the cost here show 0 to 1,000 something. Yeah, 1,150. Yeah. But when we are using index, this is 1.42, yeah, until 1. So this is in the best case, and this is in the worst case. Yeah. This is 0. for the best case, yeah, of course, yeah. But for the worst case, it will take 1,150, yeah, of resource. Okay, so this is the explain keyword. So with explain, we can see how PostgreSQL intends to retrieve data. Is it through sequential scan or through index scan? Yeah, and what is the order of the join, filter, and sort operation? Okay, the next feature is the explain analyze. So explain analyze is command to run a real query at the same time and displays the execution plan and real execution time of each step. So different from the explain syntax, yeah, explain only syntax will analyze the query without executing it, without running the query. They just perform um, something like estimation, yeah, something like estimation. Whenever this query will be executed, it will take maybe something like this, yeah. Explain before only estimate, but explain analyze will will really execute our SQL statement. So our select will be executed, and then the time and then the results will be calculated, yeah. Really calculated. Yeah, not estimated, but it is calculated, really calculated. Yeah. Okay, so for example, we have something like this: select all from pelanggan where email equals this one, and we are using the explain analyze. The result will be different. The result will be more complete. Something like this. It still has the type of index, index scan using blah 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 on pelanggan, and it also still show us the cost. But this explain analyze will also show us the actual time of execution. So the actual execution time of this query. So this means that this query takes only 0.050 seconds for each rows, yeah. And it also shows us the planning time. So before the database is running the query, usually it will planning it first. It will plan it first. Yeah. So this explain analyzing does also show us the planning time and also show us the execution time, something like this. Yeah. Okay, so this is the interpretation of the results. So PostgreSQL using index scan, yeah, and then estimated rows one, statements rows one. It means that the analyze expects the result given by this query equals to one, and then statements rows one, meaning that it really gives one. So it tells us that the estimations is correct. Yeah. And then the query completes in this one, 0.1, yeah, 0.120 milliseconds. 1 millisecond is, so 1 second is 1000 milliseconds, right? So this is a very short amount of time. Okay. And the last feature to perform query performance analysis is the PG statements. This is an extension that records the query execution statistic on the server. So this is more powerful compared to the previous statements. So instead of only analyzing one query that we type, yeah, the pgstat statements will will save the history of query executions in the form of statistic on our database server. Yeah. With this, we can understand what queries are most commonly used, which query is the slowest or the heaviest, and the average execution time of each query. Yeah. So this is important because it can help us monitor the performance of database, and it can be used to find queries that are bottlenecks. And it is very useful in production systems where there are thousands of different queries. Yeah. So this is how to use the pgstat statement. So we have to enable this first. This is just one time in each database. So for example, this one, create extension pgstat statements. Yeah. And then we want to see the 10 heaviest queries. Yeah. 10 queries that is slowest. Yeah. For example, this one. So we can do it from like this one. Select query, calls, total exec time, min exec time from PG statements. Yeah. PG statements here is, I think it is in the form of table. Yeah. PG stat statements. Order by total execution time, and it will give us something like this one. So this is very useful, yeah, but we have to enable the extension first by using this one, create extension pg stat statements. This is very useful for us. So for this, by having this information, we can tweak this specific query without the need to check all of the query. We just check the query that is the slowest ones. Yeah. Okay. Next, it is about the third topic is when we want to, how can we create and managing the indexes? Yeah. Okay, so the default or the elementary syntax for create index. Yeah. um, it is the create index command. By using this syntax, we can create the index. Yeah, we can decrease index. This index will help PostgreSQL to find data faster because PostgreSQL doesn't need to read the entire row. Yeah, but instead it goes directly to the relevant row using the index. This is the example of basic syntax in creating index. So create index and then the name of the index and then on and then the table name and then you have brackets here, and inside those brackets you put the column name. Yeah. Okay, this is the syntax of creating the basic syntax of creating index. Remember what index will be created if we are using these statements? Yeah. Of course, it will create us the B3, yeah, balance tree index. Yeah. Okay. Remember, B3 index is the default index for PostgreSQL when we are not specifying the types of the index. Okay, for example, if we often search, yeah, remember we need to create index only if it is needed. Yeah. So for example, we find that the in the customers table there are many query to find the customer by email. So we can create index in the customers column. Yeah, especially in the um, email columns. Ya. This is the example. Create index IDX pelanggan email on pelanggan. Ya, this is the name of the table, and then this is the email. Ya, email. This is the column name. Ya. Okay. With this index, query such as like this one, select all from pelanggan where email. So any query that relates to the email column, it will utilize the index that we have created. Yeah. Okay, so any query something like that, yeah, that includes email in the where statement will be faster to execute because PostgreSQL directly use indexes to find the appropriate rows. Okay. Then single index versus multi-column index. Yeah. A single index is created on only one column. Yeah. Suitable if queries typically filter with one specific column. For example, this one, create index ID transaksi tanggal on transaksi at the tanggal column, tanggal transaksi column. Yeah. Such query, the following will be executed faster. Yeah. So this one, select all from transaksi where tanggal transaksi equals to this one. This will be executed faster because we have index. Yeah, we have index in this tanggal transaksi column. Then multi-column index are created on more than one column. This is very useful if the query often uses condition of two or more columns at once. Yeah, so if in our query the user often use more than one column, so we can create a multi column index. So query like the following will be faster because PostgreSQL uses the join index. This is how we create index on two columns in one table. Yeah. So create index, the name of the index, IDX transaksi pelanggan tanggal, on transaksi ID pelanggan, comma, tanggal transaksi. This means that index is created on these two columns. Yeah. This query will be faster. Yeah. Select all from transaksi where ID pelanggan equals this one. Yeah. So this is faster because ID pelanggan is included in the index. Yeah. And then also and tanggal transaksi between this one and this one. So this one also will be faster because tanggal transaksi column is included in the index also. Yeah. So keep in mind, a multi-column index is only efficient if the order of the columns in the index matches the query pattern used. Yeah. Okay, so this is about the multi-column index. Next is about the unique index and its relation constraints. So there are special constraints called unique constraints. This is some constraint that if we want a column in our table uh, to become unique, if we don't want any value in that column uh, be the same, so we can actually use the unique constraint. There are several other constraints like primary key is constraints also, foreign key is also constraint, unique also constraints, yeah, and check for example, also constraints. So there are several different types of constraints. Constraints is actually different from index concept, right? So unique index is special because when we are creating a unique constraint in a table, so the PostgreSQL will automatically create an index for us. Yeah. So this is actually when when we want to create a unique index in our table. Yeah. So create unique index, something like this. The syntax is similar from before. Yeah. However, if we are when we are creating the table having those unique constraint, the index will be automatically created for us. Yeah. Instead of creating it manually, we just need to create the constraint, and then the index itself will be created automatically for us. Yeah. For example, like this one, we have a pelanggan table. We have a table called pelanggan, and then we modify this table by adding some constraint. Yeah. Alter table pelanggan. We add a constraint. The name of constraint is this one, and the type of the constraint is unique in the email column. This means that we don't want different rows having the exact same email, in this email column. So both command will actually result on the same thing. Yeah. So this command and this command, it will result in the same thing. So PostgreSQL will create a Unix index behind the scenes. Yeah. So the difference is that constraints are more declarative and semantically clear. Yeah. That these columns must be indeed be unique as part of data rules. Yeah. So this page of slides is just explaining whenever we create a unique index, actually PostgreSQL will create the sorry, when we are creating a constraint, a unique constraint, the PostgreSQL will automatically create the index for us also. Yeah. Okay. Next is partial index. So partial index is index that is only applied to certain numbers of rows, yeah, according to the where conditions. Yeah. This is useful when we frequently query a specific subset of data rather than the entire table. For example, in a case when we are having a system, and in the system, for example, like the e-commerce, yeah, e-commerce system, whenever we want to create a feature that shows the histories of user transaction, yeah, usually we will only show the transaction to the user maybe for 1 month before, on only 3 more before, or at maximum maybe 1 year before. Yeah. So it is seldom. It is maybe we don't need to show to the user the history that is more than 2 or 3 years. Yeah. So if the case is like that, we can instead of creating index for all of the data in from the first year, maybe from 10 years ago until now, yeah, it will cost us a lot of space. Yeah. So um, instead of doing like that, we can choose to create a partial index. This means that the index will apply to certain rows, yeah, with the limitations is set by us. Yeah. For example, here we want to create index for any transactions that happening um, no later, yeah, no we for the transaction that is happening in August or later, yeah, not sooner than August, yeah. So this is one example of the partial index. So here's the syntax. So create index IDX, this is the name of the index. On, this is the name of the table. And then you have brackets. Inside of the brackets is the column that you want to put the index. Where tanggal transaksi more than current dates min interval minus interval 30 days. This means that we only create the index for the data that is inserted into the table. The most is 30 days before, yeah, not more than 30 days ago. Yeah. Okay, so with this index, PostgreSQL will create an index only for the last 30 days of transaction. So the query like this will be very fast, yeah, because the PostgreSQL is looking the data that is included in our index. Yeah. So select all from transaksi where tanggal transaksi more than current date minus interval 30 days. Yeah. So this will be very fast. But if we, for example, like where tanggal transaksi more than 1 January 2025, yeah, so the index will be out of range. Yeah. The index will not be used. Yeah. Instead, the PostgreSQL will perform the sequential scan. Yeah. Okay, the advantage of partial index is that they are much smaller in size than full indexes. So the size of the index will be smaller. Okay, and this is how we can delete the index. So sometimes we are no longer needing the index. So we can delete index. We can delete the index to save storage space and reduce the load on write operations. Yeah. So one important information, actually index is slowing the write operation. So whenever we are not using the index anymore, we are encouraged to delete those not used index. So this is how we can delete the index. Just use the drop statement, yeah, followed by index, drop index, and then followed by the name of the index. For example, here is IDX pelanggan email. Yeah. After the index is deleted, the queries that were previously fast because they use the index may return to being slow because PostgreSQL has to perform sequential scan. Yeah. So please be careful. Just delete the index that is not useful anymore. Yeah. If the index is still used, then please don't delete the index. Yeah. Okay. This is about the creating and managing the index. And also, we have another important thing to understand. There is also negative impact of the index. So index is not always fast. Yeah? No, index is not always about faster query, faster, not always like that. Yeah. So sometimes there are negative impact of the index whenever we are not using it in the correct, yeah, case. Yeah. Okay, so actually index will spend additional storage space. Yeah. Of course, whenever we are creating an index, it will cost us, yeah, some space on our hard disk. So this is logical because, for example, if you take a look at a book, yeah, of course, the book, any book that has a table of contents, the page number will be some pages will be allocated to those table of contents, right? So table of contents in a book also cost some pages of the book. Yeah, this is the same thing goes to the index. Index will also cost us some space on our storage. Okay, and index actually can slow down the write operation. So for example, if we performing insert or update or delete on a table that has index, it will become slower, compared to the tables that doesn't have any index. And also it will put yeah it will put some, I mean, like some cost, yeah, in the optimizer module of the PostgreSQL. So if there are too many indexes, PostgreSQL must choose which index is the most optimal. Sometimes this actually makes optimizer choose the wrong strategy. Yeah. So therefore, the principle is to create an index only if it is absolutely required by frequently executed queries. Yeah. Excessive index not only waste space, but also can slow down the system. Yeah. So this is the bottom line. You have to create index only whenever it is absolutely needed, yeah, to avoid this what do we call this one, yeah, trade-off, yeah. So when we to avoid the unnecessary trade-off, yeah. Of course index is fast, but index costs us some space. It can slow down writing queries, and it can burden the optimizers, yeah. So please only create index when it is really needed by frequently used select, yeah. Okay. So the next is the last theoretical topics is about the query optimization with index. Yeah. So the ultimate goal, the ultimate mission of creating index, the ultimate advantage of index is about the speed of the query execution. Yeah. So optimization is an attempt to make SQL commands run as efficiently as possible, both in terms of time and the resource usage. Yeah. Indexes are one of the main tools in this optimization, but they must be used with caution because indexes also have additional costs. It is not always necessary to create an index. Yeah. Remember, it is not always necessary to create an index. Yeah. Okay. Okay, so we need to know when we need to create an index and when we don't need to create an index. Yeah. So usually there are some best practices when we need to create an index, such as when the columns are often used in where conditions, for example, like customer email columns or tanggal transaksi or transaction state column. Yeah. So whenever you find any column that is often used in where conditions, so you need to create an index. Yeah. Other case is when any columns is often used for join, yeah? So you need also to create an index. And next, also whenever you find columns that is often used in order by or group by, it is also will be helped by creating an index. And then when we are also finding some queries that frequently executed and slow without any indexes, so any other queries that is not belongs to these three categories. But whenever it is slow, when it is executed, so we need to create index. Sometimes index will accelerate it, will accelerates the query for many times. But on the other side, we don't need to create index when there are any tables that contain small data, for example, only few hundred rows. Yeah, so few data, you have only few hundreds. Yeah, less than thousand, less than 1,000. It is still considered as a small table. Yeah, so you don't need any index if your tables is small. Yeah, and then if the columns are rarely used in queries, yeah, so you have a table, you have several columns, and some of them is rarely used in any queries, so you don't need to create an index for it. And then when the columns have a slight variation in value, so low selectivity, for example, any column that is related to the gender, for example, something like male or female. So if the column values does not have many variety, yeah, so we don't need to create index in that case. And last, whenever the tables is updated or inserted very often, yeah, so we need to avoid creating index on that table because as I already said before, the index can slow down the process of writing data to the table. Yeah. All right. Uh, and this is how we can optimize our query by writing the index-friendly queries. So keep in mind that index is not always good for any types of query. So sometimes it will good if it is used in this type of query, but it is not good when it is used in other types of query. Yeah. So for example, in this query, the index that we have already created is not used, is will never be used. Why? Because uh we are using the where statement with function, yeah, with function. So at first we create an index for email column without lower function. But whenever we are searching the email with the lower functions, the index will never be used. The index will be useless. Yeah. So because the index created is they are creating some table, something like table of content with the email that is not in lowercase, but we are searching the value that is lowercase, so the index will not be used in that case. Yeah. So even though the email field is indexed, yeah, PostgreSQL can use it because there's lower function in that field. So lower must be calculated for each row, so the index becomes irrelevant or useless. Yeah. So the correct solution is if you really need, if you exactly, if you very sure that every search performed in the email will always be in lowercase, so whenever you are creating the index for that email column, you have to include the function also. Yeah. So whenever you are sure that the query in searching email will always be using lower function, yeah, to make your index relevant or used, yeah, you have to create index by including also the lower function, something like this. Yeah. Of course, this is applied to any other functions, yeah, string functions. Okay. So after that, the queries with lower email can be used, can use the index that we are creating. Yeah. So the important things here that you have to avoid functions or operations directly in the column if you want the index to work. Yeah. Okay, so this is the first strategy. You have to write index friendly queries. Sometimes queries is index friendly, and many other times the query is not index friendly. Yeah, so please pay attention about that one. This is only one example. Yeah, of course this apply to any other examples. Okay, the strategy number two, we can use analyze to update table statistics. Yeah. So in order to accelerate the execution of a particular query, the PostgreSQL depends on some statistics, yeah, some data that is stored in the database itself. Yeah. So this data actually containing many statistics such as number of rows, values distribution, something like that. Yeah, and if it is not updated in a long time, so it will risk the PostgreSQL to make wrong decision. Yeah. So for example, when a table have several indexes and PostgreSQL accepts some select query, the PostgreSQL will choose which index should be used. And the PostgreSQL itself will choose those index based on the value, based on the calculations that it makes, yeah, based on the values in those statistics. So whenever the statistic is not updated, the query can usually become slow. So in order to avoid that, sometimes we need to run this query, yeah, to refresh, yeah, to rebuild the statistics, yeah, to refresh the statistic, to update the statistics. Yeah. So what is the syntax? The syntax is very simple. Analyze pelanggan. This is analyze and then followed by the table names that you want to the statistics to be updated. Yeah. For example, I want to update the statistic on a pelanggan table, so I need to write it something like that. Analyze pelanggan. Yeah. So normally PostgreSQL does this automatically via auto vacuum. Yeah, but for tables that change a lot of size, yeah, change a lot of times, we can do it manually. Yeah. So with up-to-date statistic, PostgreSQL can decide on the most efficient query execution strategy. Yeah. So this is also important for us to update the table statistic by using analyze statement. Yeah. Okay, and the strategy number three, it is the query rewrite. Yeah. So so it is similar to the strategy number one. Yeah. So but if the number one is related directly with the usage of the index, yeah, this one is not directly related to the index. Yeah. So sometimes query, yeah, still can use some index, but it is not not optimal. Yeah, this is not, they not maximize the advantage of the index. For example, like the query, like these both queries. Yeah, the first one is using in, and the second one is using join. Yeah. Both of these queries will return the similar, yeah, this exact same results. Yeah, the query with in and also the query with join. This In these two examples, they will return exactly the same results. However, they will have different execution times. And for your informations, the join syntax will use the index better than the in query. Yeah. So for example, when you have a query that is initially written in with in syntaxes, in order to maximize the usage or the benefits of index, you need to rewrite it by using join syntaxes. This is the some of the most popular example of the optimization strategy in writing queries. Yeah. So differentiate between the in and join. Whenever, even though both of them are resulting in the same results, but it utilizes the they utilize the index differently. Yeah. So please prefer join compared to the in syntaxes. Yeah. So in this example, they will result in the same. Yeah. So this is actually we want to find any transactions that is done by any customers from Jakarta, yeah, from Jakarta city. Yeah, okay, so we can use it. We can find that user by using in syntax something like this. Yeah, select all from transaksi where ID pelanggan in. Yeah, so we want to find any ID pelanggan. There is become the results of the inner query. Yeah, in this one is select ID pelanggan from pelanggan where Kota Jakarta. So this inner query will remember the subquery, right? This is one example of subquery. Yeah. So this query will result in several IDs, and then several IDs will be used again in the outer queries. Yeah. This will result the transaction of the pelanggan that is resided in Jakarta City. And this is the alternative syntaxes. So we, instead of using in, we are using join. Yeah, you already learned join before also. Yeah. Select the asterisk, yeah, from transaction T, join pelanggan P on PID pelanggan equals to PID pelanggan, where P kota equals to Jakarta. Yeah. Okay. So in some cases, queries with join are more efficient because PostgreSQL can use indexes in both table at once. Queries within sometimes result in subqueries that are difficult to optimize. The same goes for other queries. Sometimes query rewrites can make PostgreSQL use indexes better. Yeah. So prefer to use join, yeah, compared to in. Yeah. Okay, so in summary, in this topic, yeah, so indexes should be used wisely. So we should create index only if, yeah, the query does need it. Yeah. So don't create any queries. Yeah, don't create any sorry, don't create any index if it is if you're not sure uh, whether the query will need it or not. And then the second one, queries should be written in index friendly way, for example without function directly in the column unless functional index has been created. Yeah, so if you really need function to be applied in the where clause, yeah, please create the index including those function. And then table statistic must be updated with the analyze so that the PostgreSQL optimizer chooses the right strategy. Yeah, this is the about the analyze syntax. And then query rewrites such as replacing in with join can make PostgreSQL more efficient at using indexes. So by understanding when to create index, how to write index-friendly queries, and how optimizers work, we can ensure that query performance remains fast even when the data is already very large. Yeah. So you will feel the advantages of the index, especially when your data is becoming large. So maybe, for example, when you created your applications, initially the data is very small, you don't need index. But whenever your data is become bigger, bigger and bigger, yeah, so you need to understand how to create index, and you need to sometimes write the previous query so it can utilize the indexes that you already created. Yeah. So I think that's all for our materials today about the indexes. And the topic 5 and 6 is about uh, fundamental index in its users, but I already explained it in the um, in the lab guide. Yeah. So maybe I will tell you a little bit about our lab guide. Yeah. Okay. Okay, so this is the practical guide for the week 5. This is about the index. So we have two topics here, topic 5 and topic 6. Topic 5 is about how we can create the indexes and how we can manage them. And in the topic 6, it is about the query optimizations. Yeah. Okay, where is the topic? Topic 5. Yeah, topic 5. And then topic 6. This one, topic 6 must be here. This is the query optimization and index trade-offs. Yeah. Okay, so actually this is like usual. Yeah, so you just need to retype or copy and paste. But again, I encourage you to type the query and not just typing and then running executing the query, but please pay attention with the results. Yeah, why it is like this, why it is like that, something like that. Yeah. So I already created the explanation for you. Yeah. And other than that, I also create a sample database with a lot of contents, yeah, in our database. This is actually a simple database. This is about online store database. Yeah. So I already prepared the database for you. You can download it in our Google Classroom. Yeah. You can import it to your database using the step something like this. So it is very easy. Actually, you just need to create a new database, and then you right click on the database and please choose create. Yeah, create database, and then create a new database. For example, you can name it as online store or toko online, something like this. After that, after you create the new database, you have to right click on them. In this one, toko online, you right click here and then choose restore. Yeah. After that, you can select on this one custom or tar, and then you can navigate to the location of your backup file. You can find the backup files in our Google Classroom, right? After that, you can click restore, yeah, and usually some error will appear. If this error is appear, then you just need to ignore it and check in the database. As long as you can find these three tables, pelanggan, product, and transaksi, the errors, you don't need to care about the error. Yeah. So usually the error is caused by the conflict of the public schema. So whenever we creating a new database, the PostgreSQL will create a default schema called public. Yeah. So the public schema will have some conflict, and it will give you some error messages like that. Yeah. But actually, as long as you can find these three tables in your Toko Online or online store database, so the error is not a problem. Yeah. After that, you can just follow the instruction given in this lab guide by retyping. I suggest you to retype, yeah, and then you can examine, yeah, you can take a look at the result, yeah, you can take a look, you can understand what is the meaning of the result. Yeah, actually, you need to understand how to interpret this one, the result of the query, yeah. So I already provide that query, yeah, with complete query in here. You can just retype the query and see the result by yourself, and hopefully you can understand, yeah, you can get more, you can grasp the concept of the index more clearly by doing this lab guide. Yeah. Okay, so I think by doing this, yeah, you can understand that the index can make the process of query become faster, yeah, like joins and filters. And also you can understand the types of indexes and what are the trade-offs of using indexes. And and the last but not least, yeah, Every optimization involves not only indexes but also how can you writing the correct queries that is index friendly. Yeah. So I think that is what we learned today, and thank you very much for your attention. Inshallah, we can meet again in our class maybe next week offline. Yeah. So thank you very much, students. Yeah, I'm sorry if there is something you don't like from me in this recording. Yeah, thank you very much. See you. Goodbye. Assalamualaikum warahmatullahi wabarakatuh.